Stator permanent magnet motor drives. In this, permanent magnet materials are located in the stator, while the rotor is simply an iron core. It has salient poles, leading to offer higher robustness for high-speed operation, and they have better thermal stability due to the permanent magnet materials. These two features are highly desirable for electric vehicle motor drives that need to operate at very harsh working conditions. There are a wide variety of stator permanent magnet machines, and some of them are considered viable for electric vehicle propulsions. It is very demanding to mount the permanent magnet pieces in the rotor, which desires to withstand high-speed rotation and severe mechanical vibrations. In addition, the rotor temperature under the trapped environment is also high, that may violate the thermal stability requirement of permanent magnet materials. Therefore, the development trend of permanent magnet machines is focused on moving the permanent magnets from the rotor to the stator position, leading to stimulate the development of stator permanent magnet motor drives. So here we are going to discuss the stator permanent magnet motors because of these advantages. Configuration of singly fed and doubly fed stator permanent magnet motor drives. Here you can see this configuration of singly fed stator permanent magnet motor drive, in which armature winding in the series solely fed by power converter. So you can see here stator permanent magnet machine is there. Now the rotor positions are sensed, armature current is sensed, and it is given to the sensors, and then it will be given to the controllers with desired command. Now the controller will give command signal to the inverter, and it will given to the stator permanent magnet machine. The system configuration of doubly fed stator permanent magnet motor is shown in this figure number 2, in which the armature fed by the inverter while the field winding is fed by a DC to DC converter. So we can see here supply from the inverter and supply from the DC to DC converter. So as the singly fed also, it has to sense the rotor position, the armature current, and that is given input as input for the controller along with the command signal. And from this, the inverter is controlled, and the supply is given to the stator permanent magnet machine, and another supply is given to the field circuit. Between the singly fed and doubly fed permanent magnet motor drives, the singly fed system has a definite merit of simplicity. It is a simple configuration, while the doubly fed stator permanent magnet motor drive has additional controllability to improve the operating performance because separately field circuit is also controlled. Both the machine topology and converter circuitry of the doubly fed stator permanent magnet drives are more complicated and costly. There are various stator permanent magnet motor drives that can be seen here. So the stator permanent magnet motor drives can be classified as flux uncontrollable and flux controllable. In flux controllable, it can be doubly salient permanent magnet type of stator permanent motor. Second, it can be flux reversal permanent magnet type, FRPM. Third, it can be hybrid excited permanent magnet, that is HEPM, which is the fully controllable. Then under the fully controllable, it can be flux mnemonic permanent magnet, FMPM. Also, they can have subclassified as HEPM, that is a hybrid excited permanent magnet, HEDSPM. Then second can be hybrid excited, FRPM. Then hybrid excited, FSPM. Similarly, another type can be FMPM, and that can be again subdivided into flux pneumonic, DSPM, that is the basic, these types with flux pneumonic. Then flux pneumonic, DSPM, flux pneumonic, FRPM, flux pneumonic, FSPM. So this doubly silent permanent magnet, flux reversal permanent magnet, and flux switching permanent magnet can be also under the flux controllable type with hybrid excited magnet, permanent magnet, and flux pneumonic permanent magnet. So here, focusing on those stator permanent magnetic machines that are viable for the EV propulsion, there are three major types: DSPM, FRPM, and FSPM. And stator PM machines with flux controllable, they are supplied HEPM and FMPM. We will see two types here. First one is DSPM. It is a doubly silent permanent magnet motor drives. You can see this diagram of schematic diagram of DSPM motor drive. DSPM machine can be considered as a combination of switched reluctance, that is SR machine, and permanent magnet brushless machine, in which the PMs are inserted in the stator back iron. The rotor is simply iron core with salient poles. You can see here, rotor is a simple iron core, and these are the projecting poles, that is the salient poles. This stator has salient poles wound with concentrated winding, making permanent magnet flux linking unipolar. So this is the rotor. Now we can see the stator. It has again salient poles. You can see these are the projecting poles. With the concentrated winding, we can see the windings are here, armature winding, making the permanent magnet flux linkages unipolar. Stator can be easily cooled by natural or air cooling. The thermal instability can be avoided or it can be made stable. So here we can see the magnets are also inserted here. Permanent magnets are inserted. The DS machine is able to work at high temperature because the cooling is efficient here, facilitating its application to electric vehicles. Another type is FRPM, is flux reversal permanent magnet motor drives. In flux reversal permanent magnet motor drive, permanent magnets with different polarities are located on the surface of each stator pole. We can see these permanent magnets on each stator poles. Inside this, we can see the rotor, again with saliency. R winding generally adopts the concentrated winding arrangement that can be seen with this. This is the winding symbol. The rotor is simply iron core. Figure shows the structure of three-phase 12 by 16 pole FRPM machine, in which there are 16 rotor poles here 16 rotor poles and 12 stator poles and 2 permanent magnet poles per stator pole. So there is also, you can see the permanent magnets which are in a pair. Differing from the DSPM machine, FRPM machine exhibits bipolar permanent magnet flux linkage because the flux linkage with each armature coil reverses polarity as the rotor rotates. The bipolar flux linkage variation can have better utilization of iron core than the unipolar type of machine. The FRPM machine inherently offers higher power density than the DSPM machine. This is the advantage of FRPM. The next is flux switching permanent magnet motor drives, FSPM. FSPM machine has attracted wide attention in the recent years. Among DSPM, FRPM, and FSPM, stator configuration of FSPM is relatively complex. You can see here into this diagram the stator configuration. In this topology, each stator pole consists of two adjacent laminated segments and a permanent magnet. You can see a permanent magnet and these laminated segments. Circumferentially magnetized permanent magnets enables flux focusing. So proper flux focusing is obtained by this configuration. In general, the concentrated winding arrangement is adopted and each coil is wound around the adjacent stator poles. The polarity of the flux linkage in the coil reverses when rotor poles aligns the successive stator tooth that belong to the same phase, so-called flux switching action. So there is a flux switching action by reversing these polarities. The next type is hybrid excited DSPM, that is HEDSPM. By incorporating the hybrid excitation into DSPM machine, the HEDSPM can be obtained as shown in figure. That is a hybrid excited DSPM. The stator incorporates 3 armature windings and DC field winding and the permanent magnet poles. So we can see here permanent magnet poles, DC field winding. The rotor has neither permanent magnet nor winding, hence offering high mechanical integrity. So this is the rotor. There is no any winding. The three-phase armature winding operates like in DSPM machine, whereas DC field winding not only works as an electromagnet but also a tool for flux control. So this is a DC field winding. In addition, there is an extra air gap in shunt with each permanent magnet. So you can see here there is also extra air gaps. In addition, there is extra air gap. The DC field winding MMF, that is magnetomotive force, reinforces the PM permanent magnet MMF. This extra flux path assists the effect of flux strengthening. It supports the flux. On the other hand, the DC winding MMF, permanent magnet MMF, the flux path will affect permanent magnet flux, find the effect of. As a result, proper design of the fields of the air gap, wide flux Next type is flux thermal magnet mode. Concept of flux pneumonia can be magnetized or demagnetized. Various can idea of using binding SPM extended to the forming FMPM flux pneumonia served as the DC excitation incorporates magnetizing line temporarily carry the magnetizing current or direct PM magnetizing wind armature wind the rotors AL all magnetizing winding incorporated temporarily carry the magnetic direct PM solving the problem field excitation applications of stator permanent magnet mode stator permanent magnet mode have high potential for application because they can solve magnet permanent and yeah as given first there are no permanent magnets in the yeah thus avoiding the problem firmly mounted high speed road and hence secondly all permanent magnets located in the thus facilitating the full carrying calling the thermal there is no issue of as the magnets are the comparison SPM, RPM, and type of track based on the power density, torque density, controllability, permanent magnet, robustness, manufacture. PM has medium power density, FRPM has power density. PM has early torque density, medium for RPM, high for also efficient PM high for ability is medium for earlier three types that is DSPM, permanent magnet, medium, speaker for FRPM, robustness very strong for medium for FRPM, medium call this film is manufacture is easy, medium for FRPM and for HEP maturity high for DS medium for FRPI, very low for